Our previous two videos were centered about the sine function and what the graph of the sine function looked like. So now what we're going to do is we are going to plot the cosine function. And so let's just take a look at what the basic cosine function looks like. And so we have our function f of x equals cos x. So we're going to complete this table of values, and then we're going to plot the cosine function. All right. So what we have to do first is we have to probably go into our unit circle, or we remember um, our reference angles, etc., or we just have the from 0 to 90 memorized. But one thing we should do is we should find cos of 0. And remember, the cosine is the x coordinate in the unit circle. And when x is equal to 0, then the output or the x coordinate is going to be 1. And then in our unit circle, if we went to cos of pi fourths, and again, we're looking at the x coordinate at pi fourths, then that would be equal to the square root of 2 over 2. And then if we were to look at pi halves, then we would see that the value there would be 0. All right. And so we could just keep filling this table out by looking at the unit circle. Okay. Just keep looking at the x coordinates. So this would be a negative root 2 over 2. All right. Because we know in quadrant number 2, the cosine function is negative. And then this would be a negative 1. And then we get another negative root 2 over 2. And then a 0, and then a positive root 2 over 2, and then a 1. Right? So that's our table of values for this. Okay. And again, all I did was I looked at the unit circle, and we looked at the x coordinates on the unit circle. Right? So now what we're going to do is we're going to plot those points. Now, you might remember in the first video in this section, I went through and I approximated all of these values for pi fourths, pi halves, 3 pi fourths by going into my calculator. All right, so just to remind you guys how I got those, for instance, pi over 4, I just literally went pi over 4 and got 0.79, right? And that's how I got to this value right here. And then I did the same thing for all of these x values. These are ordered pairs, right? And you probably remember root 2 over 2 was about 0.70 or 71, I think, okay? And of course, just in case you don't believe me, you can type that in. So we have square root of 2 divided by 2. And that was 0.71. All right, so this would be a negative 0.71, and this would be another negative 0.71, and this would be a positive 0.71. Right? And so all we're going to do is we're just going to plot these points. Okay, so I'm going to zoom in just a little bit to make sure I have a pretty good graph of this. So here's our first point, which is going to be 0, 1. And then we have 0.79, okay, which is probably just before this mark right here. And then then we had positive 0.71. All right, so that point might be like right about here if I was estimating. Okay? Then we have the point pi halves 0. Now pi halves is 1.570 right here. And then we had negative 2 or positive 2.36, which might be right about here. And then negative root 2 over 2. Okay, so that's 0.71, which might be like right about here. Right, and again, I'm just approximating these. Then we have negative 1 at pi, so we have 3.1 right here. Right? And then going back, we had 3.93, so maybe like over here. And then we had the same height. Okay, so that's probably about right here. And again, we're just using these values, we're plotting them, right? At 3 pi halves, which is 4.71, we get 0. Okay, so maybe right about here. And then at 5.5, we get root 2 over 2, so that's all the way back up here, maybe. All right. And then finally at 2 pi, which is 6.28. All right, so maybe right about here, we get to 1. All right. And so this is what one period of the cosine function looks like. Okay, so forgive me, I'm going to do my best to draw this. Right, so it goes down, and then it's going to go back up like this. Okay, so that's one period of the cosine function. And notice the period goes from 0 to 2 pi. Okay, so the period is 2 pi. The domain for this is actually going to be all real numbers. Okay, so, and that's just because we can just keep getting reference angles forever, and we could just keep having the exact same pattern, very similar to our sine function. Now notice the range, the lowest number is -1, the highest number is +1, right? So the range of this function, y, is going to be from -1 to +1 inclusive, okay? All right, now imagine that we were to keep doing this with the cosine function, all right? And that means that we could just keep going and plotting the cosine function using those reference angles. So I'm going to zoom out just a little bit again. And so what would happen is that the graph would continue its behavior in both directions. Okay? The things that are down here, these are all things that we've already seen before. Okay, so just like before with the cosine function, we can just keep getting those reference angles, and we would just have the exact same y coordinates for something like the next one would be 9 pi fourths and then 5 pi halves, etc. Right? And of course, we can go in the opposite direction and get negative values. Now, I'm going to show you what the cosine function looks like for a few more periods. We already said the domain is from negative to positive infinity, the range from -1 to 1. The function is even. Okay, remember, even means that the values are reflected in the y-axis. All right, so what that means is that if there's a point over here, then there would be another point about over here that would have the exact same property, equidistant from this axis. All right, and so if we were to extend the cosine graph, now the points here, this is what we've just plotted, okay, by using our table of values. All right. Of course, what we didn't plot was a little bit more, such as this, okay, and this would just keep going, okay. In fact, it would have like this sort of behavior, and I know I'm diverging a little bit from what the graph looks like, but it would just keep going in that pattern, and then it would just keep going in that pattern this way as well. All right, so that's what our cosine function looks like, okay. It's actually very similar to the sine function in the respect that it's periodic, okay, has the same properties. A few things that are different, though, is that it starts at the point 0, 1, where the sine function starts at the origin. And we also remember that the sine function has symmetry about the x-axis, about the origin, and then this has symmetry about the y-axis. Right. Now, one thing I want to show you really quickly before we stop this video is I want to show you the cofunction mentality. All right, so for instance, let's say I had y equals the cosine of x, all right, and that's our function, all right? And let me plot the sine function, y equal sine x, right? But what if I was to say that this would be x minus pi over 2, all right? Now, remember, this is the blue line, okay? So this would be x minus pi over 2, okay? Not pi, 0.2, pi over 2, all right? Then what would happen is it would shift a little bit, okay? So minus our pi over 2. Keep typing pi over 2 wrong, okay? So it would be a shift of that function, all right? And then if I was to have sine of x minus pi, okay, again, it would shift. And it looks like as we keep going along, that it looks like it's trying to get to the exact same sort of graph, okay? So for instance, if I had x minus, let's say 3 pi over 2, all right? Oh, well, that's the exact same graph, okay? So what we notice is that we could try to add and subtract. If I added pi halves, then the sine function actually becomes the cosine function and vice versa, okay? That's that mentality of the co-function, okay? So we know that the sine function and cosine function can kind of model each other, okay? So for instance, if I just had the regular sine function and I have my cosine, and let's say I was to shift this a little bit to the right, okay? So for instance, maybe I said x minus pi over 2. Oops, let me go back up here. Okay, then notice that these functions look exactly alike. And if I had x minus pi, okay, well, they do that the exact same thing. And then 3 pi over 2, all right? Again, if we keep moving this along, let's say I added it, there are certain ways that we can make the sine and cosine functions look like one another. That's that co-function along with the idea of the reference angles. Okay, so keep those in mind that a lot of the properties of the sine and cosine function mirror one another. Okay, it's just that they're basically shifted from one another. All right, so in the next video, what we're going to do is we're going to do the exact same thing that we did in the sine function videos, where we identify those key characteristics of the graph, such as the amplitude, the phase shift, the period, as well as the vertical transformation and the reflections in the graph.